Class, we're on section B now. I took the liberty of filling in the blank spots here to expedite time. Okay, first thing, we have our decimal. We have 0.3. This 3 is in the tenths place, so the word name will be 3/10. Next, we want to write this decimal as a fraction. So we will have 3 as the numerator and its place value as the denominator. Since it's tenths, the denominator be 10, and since the first word is 3, the numerator will be 3. Now we come here, 34 hundredths. Now we have to make sure that the 4 is in the hundredths place behind the decimal. So it'll be 0.34. 3 is in the tenths place, 4 is in the hundredths place. That is 34 hundredths. Now we need to write that as a fraction. 34 is your numerator. The place value is hundredths, so 100 would be your denominator. Now we have to simplify this fraction. Now 34 in its prime factorization is 2 times 17. 100 in its prime factorization is 2 times 2 times 5 times 5. And now we simplify out the common factors. They both have a 2 in common. So we simplify out the 2's. In our numerator we're left with 17. And our denominator we had 2 times 5 is 10 times 5 is 50. So our final answer is 17 over 50. Now if we go down here, we start off with our fraction, 7 over 1,000. So that is 7 thousandths. Now when we write this as a decimal, the 7 must be in the thousands place. So we will count. We'll put our decimal, this is tenths, hundredths, thousandths. So the 7 would be in this place value. So it'll be 0.007. Now we go down here to the 25. We have the 0.25. This 25 is in the hundredths place. So it'll be 25 hundredths. Now we write that as a fraction. 25 goes in our numerator. The hundredths goes in our denominator, which is 100. So we take the prime factorization of 25 over 100, which is 5 times 5, and 100 is 2 times 2 times 5 times 5. And we have 5's in common, so we simplify out the 5's, and we're left with 1/4. Now, we scroll down here. We go to this example. It says, write each decimal as a mixed number. Write your answer in simplest form. Now we look here in front of the decimal. This is our integer of our mixed number. So we have 3, and our mixed number, our fractional portion would be, this is 12 hundredths. So this 12 would be over 100. So now we need to simplify this. So we would take our integer, which is 3, and we would take the prime factorization of 12, which is 2 2's and a 3, and the prime factorization of 100, which is 2 2's and 2 5's. Now we simplify. We bring down our 3. These 2 2's simplify out, and these 2 2's as well. So we're left with 3 over 25. So our final answer is 3 and 3 over 25. Now we go to number 2. 64 is our integer. Our fraction would be 8 over 10. Now we can simplify this. So we will have 64, we will carry over our integer, and we will take the prime factorization of 8, which we know is 2 times 2 times 2, and then 10, which is 2 times 5. Now we simplify. We bring down our 64, and we simplify out the factors they have in common, which are these 2 2's. So we're left with 2 times 2, which is 4 for your numerator. Your denominator would just be 5. So it's 64 and 4/5. Now we go to number 3. Number 3, our integer is negative 209. Now our fraction, if we look here at the 6 is in the thousands place. So our fraction we have a denominator of 1,000. And our numerator would be 986. Now we can do the prime factorization. We'll need a little bit more room because these are larger numbers. So we could go down here and we could take 986 and we could take 1,000. Now 986, we could break it up. This would be 2 times, this would be, let's see, we will have 493. So we add 2 times 493. Now 2 is prime, and from what I can tell, 493 is also prime. Now we go to 1,000. We could break that up to 10 times 100. We know the prime factorization of 10 is 2 and 5, and the prime factorization of 100, which we solved in these other problems like number 1, we know is 2 2s and 2 5s. So the prime factorization here would be 3 2s and 3 5s. So now we will substitute those values in. So we have our negative 209, and we have to write out our prime factorizations. For the numerator, it would be 2 times 493. And for our denominator, we will have 2 times 2 times 2 times. Now I'm going to run out of space here, I do believe, but it should be 3 5s here on your denominator. Oh, just made it. Okay, now we simplify. We simplify out these 2's, and we will have negative 209, and our numerator would be 493, and our denominator would be 500. So this is our final answer for number 3. Now we scroll down to section C. Now we want to compare the decimals. Now we must use greater than, well actually it's less than, greater than, or equal to. Okay, now this is what we would do. In front of the decimal, they both have 26. So far they're even. Now the first digit behind the decimal, which is the tenths place, both of them have a 2. So they're even. So now we go to the second place behind the decimal, which this is 0 and this is 8. Since 8 is larger than 0, we will put greater than. Now we come here. In front of the decimal, they both have 0. Behind the decimal, they both start off with 1. Then they both have 2. And then you have all these zeros here and nothing here. Now whenever you are looking behind the decimal, it's assumed that after that last digit that's not 0, that the rest is zeros. So these two numbers are actually equal to each other. Now we look here. We have 2 negative values. Now remember, the one that is larger is the one that's closest to 0. Now if we look here in front of the decimal, we have this 1 and 0, and we know that this negative 0.8 is larger than negative 1.5. Now we come here to number 4. Both of them is negative. Both of them starts off with 0 in front of the decimal. Both of them have 0 as the first digit behind the decimal. Both of them have a 3 behind the decimal, well, as the second place value behind the decimal. But this number here has a 9 in the third place, and this number here has a 0 in the third place. So we know this value here is closest to 0. So that is greater. So now we're done with section C. Now we are in section D. It says we round decimal numbers the same way we round whole numbers. Locate the place value in question and look at the next digit to decide whether to round up or down. Okay, round as requested. We have 482.7817 10,000s. And it says round to the nearest thousandths. So what we would do is we would go to the thousandths place. The thousandths place is this 1 here. So what we have to do is look to the right of it. To the right of it is 7. So that means that we would add 1 to this 1. So our final answer will be 482.782. Now we do not write any digits behind this place value. So we would stop at the thousandths place. Now we go to number 2. We have a negative 0.032. And we want to round it to the nearest hundredth place. Now 3 is in the hundredths place. We look to the right of it, that is a 2. That falls into that 0 through 4. So we keep this 3 the same. So our final answer would be a negative 0.03. And remember, we do not write a number past that place value. Now we go to number 3. We have 19.643 to the nearest whole number. The nearest whole number just means the nearest the ones place. So the 9 is in the ones place. We look to the right of the 9. That's 6. So that falls in the category of 5 to 9. So that means we add 1 to this 9. Now we know when we add 1 to the 9, that'll make it 10. So this answer here would just be 20. And no digits behind the decimal, because remember, we cannot have any digits past this place value here. Now we have this example. It says pi is roughly 3.14159.265. It says round pi to the nearest 10,000s. So now we have to find the 10,000s place. This is tenths, hundredths, thousands, 10,000s. So the 5 is in the 10,000s place. We look to the right of the 5. That falls from 5 to 9. So we add 1 to this 5. So it'll be 3.1416. Now we go down here to this example. It says, example, water bills in Mexia are always rounded to the nearest dollar. Round a water bill of $24.62 to the nearest dollar. Now we know to the nearest dollar is the ones place. So we go to the ones place. This 4 is in the ones place. So we look to the digit to the right of it, which is this 6. So that means we would add 1 to this ones place. And that would give us $25. Now again, remember, you cannot put any digit past the place value you're rounding. Now you can have digits in front of it, but not behind it when you're dealing with decimals. And that is it from this section.